Welcome back to our discussion about quadratic equations. And in this video, we are going to focus our attention on solving quadratic equations by using the quadratic formula. So there are lots of different methods for solving quadratic equations. And we've talked about a couple already, and we've got another one or two to go. But when we're talking about solving quadratic equations, there is one tool that is more powerful than any other, and that is not the rock. That is actually the quadratic formula. The quadratic formula can be used to solve any quadratic equation, and it is the tool that is the most versatile of any of the tools for solving. So let's look at it for a second. The quadratic formula is defined to be x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And this is true when the quadratic equation is in the form ax squared plus bx plus c is equal to 0. Notice all of the terms of the equation are on one side and it's set equal to 0. This must happen before you apply the quadratic formula. Otherwise, you will have sign errors, and we don't want that. Okay, so let's walk through an example of using the quadratic formula. Let's solve the equation x squared is equal to 2x plus 4. All right, well, if we can only use the quadratic formula when the quadratic equation is set equal to 0, that's the first thing we're going to want to do. Let's bring that 2x and the 4 to the left-hand side of the equation and set it equal to 0. All right, x squared minus 2x minus 4 is equal to 0 is our result. And now what we will want to do is identify what are a, b, and c. A is the coefficient to the x squared, b is the coefficient to the x, and c is our constant. So in this case, a is equal to 1, b is equal to negative 2, and c is equal to negative 4. Now what we're going to do next, we are going to take that quadratic formula and substitute everything into its proper place. At this point, don't take shortcuts, just substitute in. Okay, so everywhere you see a b, you're going to replace it with negative 2. Everywhere you see an a, you're going to replace it with a 1. And everywhere, well, the one place you see a c, you're going to replace it with a negative 4. So let's do that. And this is our result. Now it's a little bit ugly in this form, but we have everything in its rightful place. Now notice, if I'm looking at this, I really can have three parts of the quadratic formula. I've got what's in front of the plus or minus, I've got the radical piece, and I've got what's underneath the fraction bar. Okay, so we're going to simplify all of those pieces, but I'm going to take just a second and simplify the radicand first. Let's take negative 2 and square it, and that would give us 4 minus 4 times 1 times negative 4. Well, 4 times 1 times negative 4 is negative 16. So I have 4 minus negative 16 under the radical, which is the same as 20, because that minus negative turns into a plus. Okay, so let's go ahead and rewrite this in a little bit of a simpler form. That negative 2 is just going to be 2, and this 2 times 1 is just going to be 2, and what's under the radical is just going to be 20. So we end up with something that looks like this. We're getting closer and closer to our end result, but we're not quite there yet. Notice that square root of 20 can be simplified. 20 has a perfect square factor of 4, so I can break that into the square root of 4 times the square root of 5, which is 2 radical 5. Okay, so I have 2 plus or minus 2 rad 5 all over 2. Now I want to clean this up a little bit. And what I want to do is look for any common factors in the numerator and the denominator. Now, there are three places I'm looking for a common factor. Here they are. What's in front of the plus or minus, what's in front of the radical, and what's underneath the fraction bar. Notice in all of these cases we have a factor of 2. So I'm going to factor that out of the top and the bottom. And what I have as a result is 2 times 1 plus or minus rad 5 on the top and 2 times 1 on the bottom. Now that 2 over 2, that's the same as 1. So I can cross those out because that's the same as saying 1 times that result, 1 plus or minus rad 5. And so our answer is 1 plus or minus square root of 5. Remember that this is really representing 2 answers, and we would want to write our solution set as 1 plus square root of 5 and 1 minus the square root of 5. Okay, so that is the process of using the quadratic formula. Let's do a couple more examples together. And if you feel confident, you can try moving ahead on these and checking your work. Pause the video and then go ahead and check. Okay, so let's try these 2 examples right here. 2x squared is equal to negative 3 minus 4x, and x squared minus 6x minus 9 is equal to 0. Okay, so in the left-hand example, remember that we want to put our equation in standard form with everything on one side and set it equal to 0. So I would end up with 2x squared plus 4x plus 3 is equal to 0. Take a minute, identify your a, b, and c. A is 2, b is 4, and c is 3. Use our quadratic formula and substitute the appropriate values into the appropriate places. So, negative 4 plus or minus the square root of 4 squared minus 4 times 2 times 3 all over 2 times 2. Okay, let's simplify our radicand by evaluating what's underneath the radical. So 4 squared is 16 minus 4 times 2 times 3, which is 24. So 16 minus 24 gives us a radicand of negative 8. Let's rewrite our entire expression with all 3 pieces simplified. So we would have negative 4 plus or minus the square root of negative 8 all over 4. Simplify the radical. So the square root of negative 8, if you have a negative under the radical, we're going to have an imaginary number. So it's the same as the square root of 8 times I, which is the square root of 4 times the square root of 2 times I, which is 2I rad 2. Now, looking at those 3 pieces of the expression, what is the common factor there? Now, if you said 2, you'd be right. We're going to factor that out of the numerator and the denominator. So in the numerator, we would say 2 times negative 2 plus or minus I rad 2. And in the denominator, we would say that's 2 times 2. And then we would cancel out those common factors of 2. And our final answer would be negative 2 plus or minus I rad 2 all over 2. Write your solution set as 2 distinct answers, negative 2 plus I rad 2 over 2 and negative 2 minus I rad 2 over 2. And that will be our final solution. All right, last but not least, we have x squared minus 6x minus 9 equals 0. And it's already in standard form, so I can kind of skip that step and just go ahead and identify my a, b, and c. A here is 1, b is negative 6, and c is negative 9. So let's go ahead and substitute those into the quadratic formula. So we would have negative 6 plus or minus negative 6 squared minus 4 times 1 times negative 9. And that's all over 2 times 1. So let's simplify our radicand. Negative 6 squared will be 36 minus 4 times 1 times negative 9, which is negative 36. So I would have 36 minus negative 36, also known as 72. Let's clean up our expression. That negative 6 becomes 6, and that 2 times 1 is 2, so x is equal to 6 plus or minus the square root of 72 all over 2. Simplify the radical. That square root of 72 breaks into the square root of 36 times 2, and that's 6 rad 2. So 6 plus or minus 6 rad 2 all over 2. Look for common factors. 6, 6, 2, they all have a common factor of 2. Let's factor it out of the numerator and the denominator. 2 times 3 plus or minus 3 rad 2 all over 2 times 1. Divide out our common factors, and we end up with our final answer of 3 plus or minus 3 rad 2. Writing our solution set as two distinct answers, we have 3 plus 3 radical 2 and 3 minus 3 radical 2. Okay, now it's up to you to practice this strategy. And like I said before, the quadratic formula is the most powerful tool you can put in your toolbox when it comes to solving quadratics because it works with everything. So take some time, get familiar with it, learn how to simplify, and you will be well suited for any time you need to solve a quadratic equation. Next time we'll talk about solving quadratic equations using graphing, and I will see you then.